Hello everyone. Today we will discuss about a specific topic, matter. You know what? We cannot touch air, sky or something like these, but we can touch ice, water, even vapor. Then the substance we can touch, we can sense by our sense organ, and the substance which has a definite shape, a definite volume is called matter. There are mainly three types of state in the matter. These are liquid, solid and gaseous. And the main characteristics of matter is there are a specific intermolecular force of attraction in between the particles in the matter. And when the diffusion process occurs, the particles actually avoid this force and can move from high concentration to low concentration. Using a specific kind of energy, the energy used for the movement of the particle is called kinetic energy. Now, we can compare different states of matter, such as solid versus liquid versus gas. Solid matter has definite shape and definite volume. It is incompressible. Besides sponge, because sponge has a pore in the middle and in the pore there is air, and when it is compressed the air expels out. So in spite of being a solid substance, sponge is compressible, but all solid matter are incompressible. Okay, then we can tell that the intermolecular force of attraction in solid matter is very high. So the diffusion rate is very low. Actually, what is diffusion? Diffusion is the movement of particle from high concentration to low concentration. If there is intermolecular force of attraction is very high, so the diffusion rate will be very slow. Now, what is the density? Actually, density is mass per volume. In 1 unit of volume, the amount of mass is present is called density. The density of solid matter is very high, and the kinetic energy used for the movement of the particle during diffusion is also very high because the force is very high. Intermolecular force of attraction when is very high, the diffusion rate is low. So the kinetic energy used for the movement should be very high. In this matter, we can tell there is a short difference between diffusion and osmosis. Diffusion is the movement of particle from high concentration to low concentration. But in osmosis, there is use of semi-permeable membrane. Through this, the water particle can move, and the movement is obviously from high concentration to low concentration. Now, what we tell about liquid? Liquid matter has its definite volume but not the definite shape. Here, it can flow from one place to another. So this is fluid, this is incompressible. The intermolecular force of attraction in liquid is lower than solid but higher than gaseous substance. So diffusion is opposite. Diffusion rate in liquid is higher than solid and lower than gaseous substance. Here we can tell the diffusion rate is inversely proportional to the intermolecular force of attraction. Now we can tell about the density of the liquid. Density is low here in compared to is lower than solid, but the density is higher than gas. So liquid in the middle state in between solid and gas. Here we can tell for gaseous substances that it has not any definite shape and volume. There is no definite shape and volume in the gaseous substance. This is highly compressible because we can see for LPG and CNG gases, these gases are compressed in the cylinder in the form of liquid. When it is compressed and is kept in the cylinder, the gaseous substance is converted into a liquid form. The intermolecular force of attraction is very low, the diffusion rate is very high, and the density is also very low. The mass per volume for the gaseous substance is very low. Okay? This is the main comparison statements we can provide for solid versus liquid versus gaseous substance. Now we can see that there is interconversion between these states of matters. Different types of interconversion process is here. Number one, it can be solid state to liquid state, it can be liquid state to gaseous state, and the opposite here, it is also from gaseous state to liquid and liquid to solid. Now, I will tell you a specific example for this interconversion. When ice is converted to water, means solid is converted to liquid, this is called melting, fusion. Okay, melting, fusion. When liquid is converted to gas, just for example, above 100 degrees Celsius, water is converted into vapor. The process is vaporization. The opposite is also true. The gas is converted into liquid. When the vapor is converted into water, this is simply condensation. And in the process of freezing, okay, in the process of freezing, the water is freezed into ice particle. So this is the interconversion between liquid and solid. Okay, I repeat, there is fusion and vaporization, and the opposite is condensation and freezing. Sometimes what happens, the solid state is directly converted into gaseous substance. The process is called sublimation. Okay, and the opposite also true. The gaseous substance keeps the state liquid and directly converted into solid state, and the whole process is called deposition. Okay, this can be seen in ammonium chloride, camphor. These substances are called volatile component. Actually, there is a specific formula we can provide for you, that is the degree Celsius, degree Kelvin, degree Fahrenheit. Okay, the formula we should note that degree Kelvin equals to degree Celsius plus 273, and when the conversion is between degree Celsius and degree Fahrenheit equals to 9/5 degrees Celsius plus 32. These two formula are very important because the mathematical problems will come in your questions papers, and you should use this formula to solve your problems. Okay, so degree Kelvin equals to degree Celsius plus 273, and degree Fahrenheit equals to 9/5 degrees Celsius plus 32. Okay. Now, the interconversion of the state of the matter depends on some factors. The factors are temperature and pressure. Okay, when temperature is increased, the intermolecular force of attraction is decreased. This is inversely proportionate. So, when the intermolecular force of attraction is decreased, what happens? The solid is converted into liquid, and liquid is converted into gas. Okay, then the temperature is decreased, then intermolecular force of attraction is increased, because this is inversely proportionate. So gas is converted into liquid and liquid is converted into solid. Now the pressure, about the pressure we can see this is actually directly proportionate. What happens when pressure is increased? The force of intermolecular force of attraction is also increased, because when LPG gas in CNG gases, when the pressure is increased, these gases are compressed into the cylinder by pressure, the gas is converted into liquid. And what happens? The intermolecular force of attraction in liquid state is higher than the gaseous substance. So pressure and intermolecular force of attraction is directly proportionate, and temperature and intermolecular force of attraction is inversely proportionate. We should note down this, okay? Then we will tell about a specific type of heat called latent heat. What is latent heat? When the intermolecular force of attraction from one state to another in matter, it can be solid to liquid, it can be liquid to gases, but there is no increase in the temperature. First of all, we should note down that there is a specific difference between gas and vapor. Do you know what is this? I will tell you. Gas is the gaseous substance in normal temperature below 100 degrees Celsius, because oxygen, carbon dioxide, nitrogen, these are all gases, but the temperature is below 100 degrees Celsius in room temperature. When we can notice the gaseous substance is present above the 100 degree temperature is called vapor, because water is converted into vapor above 100 degrees Celsius. Okay, so in normal temperature is fully gas, but in higher temperature, that is above 100 degrees Celsius, this is vapor. Okay, and there is another information you should note down, that the fluid. What is fluid? Actually, the substance can flow from one place to another is fluid. In that case, liquid, also gaseous substance, both are fluid. Fluidity is a characteristics, is a physical characteristics. We should note down that this is not only for the liquid, but also for the gaseous substance. Liquid and gas both are fluid. Okay, the rigidity is another type of physical characteristics found in the solid state. Okay, then this is the main difference between rigidity and fluidity. Okay, then about the latent heat. Here is an example. Okay, ice cube is present in a bowl full of water. A bowl is filled with water, and in the water, ice cube is present. After some time, we can notice ice cube is converted into water. Why? There is no increase in the temperature. How ice cube is converted into water? Actually, in ice cube, there is less heat, less energy. But in water, there is, compared to the ice cube, there is more high heat energy. Using that energy of the water, ice cube is converted into water. In this way, this hidden heat energy in the water is called latent heat. Using latent heat, any substance can convert it into from one state to another without the increase of the temperature. Now, there is two types of latent heat. Latent heat of fusion and latent heat of vaporization. When the heat energy used to convert 1 kg of solid substance into 1 kg of liquid substance at atmospheric temperature, atmospheric pressure, without the increase of temperature. This is a main point. Without the increase of temperature is called latent heat of fusion, because normal fusion is what? Is an interconversion between solid to liquid. And latent heat of vaporization. Vaporization is what? The process, the interconversion process between liquid state to vapor. So, the heat energy used to convert 1 kg of liquid state into 1 kg of vapor at atmospheric pressure, the heat energy is called latent heat of vaporization, because there is no increase of the temperature. This is two types of latent heat. We should note down here, and the question will come, okay, about this. Now, a different process it calls evaporation. What happens here? Actually, in evaporation, the interconversion process from liquid state to gas, but this is below 100 degrees Celsius. I can tell you, vaporization is the interconversion process from liquid to gas, but this is above 100 degrees Celsius. When this is below 100 degrees Celsius, this is normal evaporation. There is an example, okay? What happens in the rooftop? We spread our wet cloth and under the sunlight, this is dried up. How? The liquid particles in the wet cloth is converted into gas, but there is no increase in the temperature. This is below 100 degrees Celsius. But normally, using the sunlight energy, the liquid particle is converted into gaseous particle. This is evaporation. And actually what happens in summer season, we are sweating, we use light clothes. This light clothes actually absorbs the sweats from our body, and this sweats is converted into gaseous substance, and a specific energy is used here to convert this sweat into gaseous substance using from our body. So our body temperature decreases, we feel cool. So we are safe to wear a light cloth in the summer season. That's why the sweat is converted into gas using our body temperature, and we feel cool in the summer season. And for evaporation, there are specific factors. You know what? The surface area. We spread the wet cloth in the rooftop so that the evaporation rate should be high. In the wind season, in the dried summer season, the evaporation rate is high because the sunlight is high, the wind speed is high, so evaporation rate is also high. The conversion between liquid particle to gaseous particle is high. But in the humid season, when the air is full of humid particles, the interconversion rate from liquid to the gaseous, the evaporation rate is low. So this is the main factors actually affects the process of evaporation. Now lastly, I will tell you a specific two types of states other than solid, liquid and gases. What are they? They are plasma and Bose-Einstein condensate. They are a specific type of states other than solid, liquid, gases, and these are last two states of matter. Firstly, I will tell you the plasma. Actually, what is plasma? Superactive, super excited, super ionized gases are called plasma. In neon gas bulb, the bulb is glowing. How? In this bulb, there is super excited, super energetic, super ionized gas such as neon, helium, and also the fluorescent bulb. And with the use of these gases, the electricity is used here, and it is the main purpose to glow the bulb. Okay. Now we can notice actually the sun is glowing, the stars are glowing because there is presence of plasma, and the plasma actually uses the high temperature to help them glow. Okay, and there is another type of state of matter is Bose-Einstein condensate. What happens at very low temperature? Gaseous substances normally with low density. In gaseous substance, we told you that there is very low density. At very low temperature, the gaseous substances is converted into solid particles. For example, dried carbon dioxide. Dried carbon dioxide is a Bose-Einstein condensate. Gaseous substances is converted into solid particle. This is normally condensate. This type of condensate is discovered by Satyendranath Bose and Albert Einstein. So by using their name, the condensate is called Bose-Einstein condensate. And from this topic, the main questions will come: what is matter? What is the main characteristics of matter? What are the comparison between solid versus liquid versus gases? What is the main effect of temperature and pressure on the interconversion of state of the matter? What is evaporation, and what factors actually affect the rate of evaporation, and lastly, what is plasma and what is Bose-Einstein condensate. And I told you there are some problems related with the temperature conversion, so we should note down these two main formulas. And if you have any type of questions, please note down at the comment section, and I think the whole whole discussion is going to be useful to your study. So please, if you like this video, please download Google Play Store Knowledge Flame app, and please subscribe YouTube Knowledge Flame channel. Thank you.